Okay, so real quick video here, making a note card and building on the definition of work. So we already knew that work was defined as the change in energy on a system. Again, I cannot emphasize enough, guys, that you have to memorize that work equals change in energy. And that's what this lesson is about anyways, because very often they will say, what's the change in energy of the system? And you need to be thinking in terms of work. Rather than just like, oh, well, what was the initial energy to begin with? What was the final energy to begin with? So really be focusing on that. So again, remember that positive work means energy was added to the system. Meaning, now I should specify here, I really need to fix these notes for next year. I was trying to be clear here and I need to be more clear. Meaning the object was sped up typically. Sometimes, again, we can add potential energy even if we're not speeding the object up. So we have to be careful about that if the system includes the Earth. So add here if system, system, that says system, includes the Earth. I'm going to be adding those notes for next year. So if our system happens to include the Earth, so say if I got my stapler here, and I'm talking about the stapler Earth system, and I raise the stapler, I added potential energy into the system because the system includes the Earth. Remember that if I am talking about the stapler by itself, and I raise it, the stapler by itself cannot have potential energy, so I actually didn't add any energy to the system. I know it's confusing, guys. In this lesson, we're going to really emphasize why that distinction matters. The difference between the stapler and the system of the stapler and Earth. So again, if the Earth is included in the system, we can add potential energy, not necessarily kinetic speed. So negative work, again, means that energy was subtracted from the system, meaning the object was slowed down, or again, maybe I took the height away if the system includes the Earth. We will clarify that in this lesson. So really quickly here, I want you to make this note card. Now I'm going to have you guys add one more thing on here for later when we're studying for the AP test, actually. So this is the work energy theorem. So again, because we know that work equals the change in energy, work can equal the sum of all the changes and all the possible energies. There is one energy we're not going to learn until Unit 6, and it is spring potential energy. If any of these things don't apply in the situation, you just ignore them. But if you could please add here on the end, this is US. So UG is gravitational potential, US is spring potential. So again, what this means is that all the work added together equals the sum of the change in every type of energy in the system. So you have to know what the system is. This is a very important concept here. If there are no forces acting outside the system, the network is zero, because if there's no forces acting outside, what type of system is it? Closed, which means there is no work being done on the system. The energy is constant. So please take a second, copy this down, and then click continue when you're ready to go. Okay, so again, this concept in particular is really important to understand. And I want to really quickly relate this to Fnet. Now we know that Fnet equals ma because of Newton's second law, but we also know that Fnet equals the sum of all the forces in the system, or acting on the object. So if I said F1 plus F2 plus F3, we know this can also equal ma. This is the same idea. We know that work equals FD. So FD can equal the changes in all of the energy of the system. Yeah, these two things exist together. FD exists with all of the changes in the system added together. Okay, going on to the next slide. So let's talk about friction now. So because, again, a lot of times when we have an open system, usually these problems are talking about friction acting on the system. Friction, usually what they do is they say that's outside the system. Usually you don't include friction inside. So, as friction always acts opposite the direction of motion, the force of friction will always do negative work on an object, meaning it subtracts energy and slows the object down. So friction, again, the purpose is to slow the object down. So friction always pulls from kinetic energy, and again, slows the object down. So we call this energy loss dissipated energy. Again, we know that energy cannot be created out of thin air and it can't be destroyed. Again, even to raise this thing here, that energy had to come from me, my own internal energy. So I'm going to really quickly show here this E internal we're going to talk about more. We kind of lump all in this class, all together energy, all energies that are not kinetic potential, into E internal, because that gets very complicated. Again, in order for me to raise this, I have to be alive, and being alive takes energy. So this kind of, again, just sums up whatever energy I had in my body that allowed me to raise the stapler. So again, energy does not just get created out of thin air. Yeah, has to come from something. Every single energy has to come from something. Therefore, again, it cannot also be destroyed. It has to be converted into a different type. So this dissipated energy, very often, most of the time, it gets converted into heat and sound. So we consider that energy to be dissipated because we don't see heat and we don't see sound. We can hear it and feel it, but then it's gone. And again, it's not gone, actually. It got dissipated throughout all the other molecules around us. When I rub my hands and create this heat, you feel it go away. What actually happened is it dissipated into the air and spread out enough that you can no longer sense it. Yeah, there's thermodynamics going on there. So once more, we should know that friction creates heat. My hands feel hot and sound. You should be able to hear that, right? So again, this energy was not destroyed because energy cannot be destroyed due to the law of conservation of energy, but it's also no longer kinetic or potential. Yeah. So again, we tend to put this into a catch-all called E internal. Yes, again, there's some other energy coming from like my own body. We just call this the internal energy of the system. Yeah, that's heat and sound. So when we're specifically talking about friction, the work done by friction equals the change in E internal. They will reference that. Yeah. So again, if we lost, again, I don't want to say it's gone, it dissipated. If we lost energy due to friction, the change in the internal energy of the system equals the work done by friction. And since work equals FD, take a prediction over what the formula is for the work done by friction. It's the force of friction times the distance. Now again, it's negative because friction is going to be taking away energy. Yeah, it's going to be slowing the object down. So we're going to pause there. We're going to build upon this in the rest of the lesson. This one's a little bit of a longer lesson because we're building upon two things actually. So tomorrow we will continue with this.